Hi, welcome everyone. In today's video, I'm going to show you how to do ARCH and GARCH models in Stata. And for that, the code shown on the right hand side will be done step by step. The font size, I try to make it big enough so that you can have a look and you can copy the codes while I am discussing. So first of all, we'll discuss about the data. So I'm using this command to load the wholesale price index data, and in this data you can see the values of wholesale price index and log of wholesale price index and their first difference as an inflation. So this data is quarterly data from 1960, and it has around 124 observations. I have intentionally kept five extra observations so that I can do a forecasting later on. So now we'll move forward towards the data analysis. So first of all, we'll have to check if the data is stationary or not, because ARCH and GARCH models are applied on the models which are variables which are stationary. So we have to have a look if our selected variable is stationary. So that is done by unit 2 test. This shown is here. So but the problem is we need to see how many legs we need to use to check the stationarity. For that, the command is VARSOC, vector error correction specification order criteria test. Okay, so it's a lag or lag selection criteria, vector auto correction, so specification order criteria. So here you can see the most of the stars are at lag 4. 1, 2, 3, 4. Only one is at lag 2. So I will use lag 4 in the Dfuller test to check inflation. So when I check it, I came to know that it is significant at 10%. So I can conclude that it's a random walk without drift. So it means it is random walk means it is stationary. Without drift means it I have not added the trend variable here. If I add a trend, it will say it is a random walk with drift. So so if we need to add trend or not, how we can have a look? So we can, first of all, we have to declare data as a time series. So have a look if the commands are already here. I will run those. So TWSET T. So I will declare data as a time series. Okay, so quarterly data is declared. Now I will generate a TS line data inflation, a line chart with time series. So it is working on the data. You can see the graph here. There is no clear increasing pattern. It was slowly increasing. It was slightly increasing, then it started to decrease. So there is no increasing overall or decreasing pattern. So we cannot conclude that there is a trend in the data. Other things that you observe, that there is a low variability, then high variability, then low variability. It is already discussed in the remaining codes. So we'll come back now. This was the first thing, that variable is stationary. Second thing we need to see is that does the variance of the data change throughout the data. If the variance change, we can conclude that there is volatility that would lead to making of the arch and GARCH model. So that command is low and McKinley variance constancy test. So it's not installed in my computer, so I will install it. SSC install low McKinley. So it is installed now. So you can see installation complete. So I will come back and run this command again. So it says that it checks that if the variance is constant or not. So it is comparing different ranges from two quarters to 4 quarters to 8 quarters. So it is comparing set of 2, set of 4, set of 8, set of 16. So all of them are significant. This is showing that variance is changing when we compare two observations across each other, two observations next two, or four with next four and next four. So this says that the variance is not constant. This was also visible in the graph that the variability was changing. So this shows that we can use ARCH and GARCH model, because in that model we will make an equation for the variance. Now, first of all, we will make the ARMA model. For that, we need to know how many AR, and for how many MA we need. So for AR, we use PAC, and for MA, we use AC equation, autocorrelation graph and partial autocorrelation graph. So AC function, when we run it, it will make a graph. I have done it only for 10 observations. You can increase it in the command. And in this command you can see that this is the coefficient value of first lag of error term, second lag, third lag, fourth lag, fifth lag, so on, 10th lag. You can notice that there are a 1 2 3 4 5 6 lags significant before the first insignificant lag arrives. Okay, so it means there are 6 ARs. If there was one significant and other was insignificant, it doesn't matter how many significant later on. You only count up till first insignificant event. So 6 ARs are there. So we'll close it. I will note down somewhere. Uh, but now we'll see PAC. There is only one, two. You cannot count this one because it's on the after the insignificant. So there are two ARs and 6 MAs. So we'll come back and we'll first of all have a look at the details. So we'll run this core gram function. It also gives me the similar things. So these are the significant components, and this is significant in. So there are 2 significant in AR, and there are around 8 significant in MA. So we'll run the command arch. So since the variable is stationary, we don't need to change the variable, otherwise we need to use the stationary form. And now we'll add AR. So we found out there are 2 ARs, and we'll start with 2 ARs, so 1 to 2, and there are 8 MAs or 6 MAs in the graph. So we'll start with 6 and we'll reduce it if they are not working. So I will run with this graph. So this is ARCH model with AR2 and MA6. So you can note here is that when I run AR2, so the first one is insignificant. So we cannot run, we need to make sure the lowest one is significant and the highest one can be insignificant. So yeah, I might have to drop the highest one. In the MA, there are few significant, few insignificant. So what I will do, I will come back to the model again and drop one from here, and let's say drop one from here, and I will run it again. Now first one is significant and there is insignificant at the end, so I will drop few more from the MA. We need to make sure that most of them are significant, otherwise there is no benefit of forecasting if they are not significant. Now it's better because last one is significant, there are few insignificant, and first one, so it's better than the previous case. You can further improve by reducing it, and the best way is when you are reducing, you can note down the AIC and SIC values. You can generate that, and then and compare which one has lower, and then stop there. So for that you can go in statistics and see the post regression options. Other and you go in post regression, post estimation, and you can look for specification, diagnostics, and goodness of it. Yes, information autocorrect. So when you click this, you want to get information. So when you press this, it will give you this command stat IC. It will give you AIC and SIC values. So when you are reducing the lags, you can note down these values. The lowest value The model which has the lowest AIC and BIC is the best one. So you can if there is a ambiguity which one is best, you can use this method. Next we go towards prediction of residuals. So I will predict the residuals of the model and then predict the variance also, and then I will also store the results in a table. Now, if we want to see if there is a arch and GARCH effect present, we only have made a model of ARMA but not arch and GARCH yet. So I will use residuals and make the choreogram same as what we do for inflation. So we are now exploring the error term of our ARMA model if we see that there is any patterns. So when I do it, there isn't any significant AR or MA. So we can go in detail by creating AC plot. So AC resid 1 lags 10 level 95%. So we'll do have a look at that. Control D. So no, none of them are significant. All of them are inside. So we'll copy that and do a PAC plot. None of them are significant. So the PAC plot is actually lag of that variable. So if it's a resid1 error term, then lag of error term, second lag, third lag, and AC plot is error term of the model, first lag, second lag. So this way. So it means there is no problem in that. So now we'll draw a graph, have a look. So this is the graph of residual of the ARMA model. So you can note that it is way smoother than the actual inflation chart that we showed earlier. There is no cycles. There is few portions where there is volatility, but rest it is more horizontal as compared to the previous one. So this is a smooth graph, but we can have a look now if there is arch inverse effect present or not. The AC and PAC plot were there to check if there are any other AR or MA portion present that we could add or not. Now what we'll do, we'll done a simple regression point without a variable. So resid as a dependent and no independent variables. Here a constant is actually the mean value, and a t value shows that the mean value is actually 0 because it's insignificant. So by definition error term mean is 0. So this is also confirming that. So in that regression we'll check for arch effect. So I will use this command, and it has shown that at 0 lag, 1 lag there is no artifact, but at 2 lags there is. I can check for more lags, like I will go up to 3. So it has artifact. So what I'll do, I will go back to arch equation and I will start with arch 1, 2, 3. So I have confirmed AR1, MA4, but arch 1, 2, 3. So I will run that. It will take more time because the model is now more complicated. So you can see all of them are insignificant. We will reduce it so that there is some significant portions, otherwise it will not be useful. Still insignificant. By at 2 lags, I will move it to 1. It is significant now. So this way arch effect is there. Now what we'll do, I will generate the residuals again, and I will check the variance equation again and store the results and see if this new residuals. The purpose is if the residuals, the variance in the residuals are removed, we don't need to go forward. So it is more smoother. How we can notice that the upper and lower limits are more nearer, but there is still a spike here. So we have to move forward and try to find a solution for this. These are the variance. You can see there is a spike in the variance. Otherwise the variance was very small. Now we'll go for, have a look if there is, and see in the residual there are some significant portions. and we can compare both residuals, the resid 1 after ARMA and resid 2 after ARMA and ARCH. You can see the standard deviation is a little bit bigger. So we'll run the second residuals and look for archlm again, and you can see there is significant portion. And now since we have already added a arch, so this portion will measure the GARCH part. So we'll run the GARCH from 1 to 4 because all four of them are significant. So we'll run that. You can see here that has not converged, so model is more too complicated. So we'll reduce the lags and have a look at it again. So it has still not converged. I will reduce the lags again. So this sometime it will not converge because of the data nature. Maybe data is not long enough, or that complication is not converging. So it has run. So you can see there is two significant in MA, one yeah significant. GARCH is not ARCH is not significant, but two GARCH are significant. So another way is that you can either run with this or use only one GARCH, but for that you can just have a look AIC value where it is smaller. I would prefer a significant arch and a significant GARCH with lesser GARCH values rather than more. So there's not much difference. Still, it is not significant. I can have two GARCH. So the decision is based upon the AIC value. So you should also store the AIC values and have a look where it is smaller and stop there. So the problem here was, should I keep two or one? Technically you should keep two because both of them were significant, but my objective was to try to make sure arch was significant, but arch didn't came out to be significant. Either I will to improve the efficiency, either you can remove the arch or try more lags. Now I will try to complete this video so that you can understand the steps. I will store the residuals, I will store the variance model residuals, uh, and then I will store the results. I will try to plot the graph of the residuals so that we can see what is the nature. Now still there is one, so this, if they are not converged, that it means there is some event that has happened here. So you can explore that and add a dummy variable, but when I use this, I will notice that the residual 3 has even though it has a little higher mean, but it has smaller variance standard deviation as compared to arch model. Okay, and the maximum value is also smaller than arch model. Now you can go further. I have done more commands, like I've then checked it again and then add two lags, and then I will run it quickly. So I will model again two lags and predict the residuals, two lags of GARCH. Okay, and then store the residuals, store the model, try to see the graph. So this is the graph here, and then you can still compare the residuals and move forward. So by the end you can compare the results using this command, because I was storing all of them. Here I can get the value of AIC, and then I will, so what I was intending to do is that you can now have a look at all the models and then see the AIC values where it is smallest. So it was smallest here, it's negative number, and it's smallest, it is smallest here. So this model is more suitable based upon the AIC value. Then now next point was to do the forecasting. So this command tsappend, it adds 15 observations in the data. I will run the model again quietly. The quietly means it will not show you the results. It will only tell you that estimations are done when there is a new line shown. So in the background, estimation is done. Now I will predict the variance of the inflation from the variance equation, and predict the inflation from the mean equation, and then I will predict error in the inflation. So how much prediction error was there, and then I will plot the error prediction, how much was there. So this was the error in the prediction in the model, okay, which we already plotted using error term. Now I wanted to generate the upper and lower limits. So this is the upper limit and lower limit for the forecast, and then I will plot the forecasting graph. So this is showing the prediction XB, and this is upper limit and lower limit. So this is showing me the predictions. So I hope you understood the model. The difference in the video is that when you use your data, you will have totally different way of adding the lags, because it totally depends upon the data value. Secondly, I try to tell you that how to ensure that the lags are enough. You can have a look at the AIC values, and then at the end these commands are there. So what I will do, I will make it a full screen, so you can store these, have a read at it by taking a screenshot, and I will start from the top and slowly bring it down from here. So you can stop it screen at here and type the commands. These are the sets, then the last set. Okay, I hope you understood the process, and this way you can go for advanced models, as there are many more models other than ARCH and GARCH. Like, you can add more types of things in it, like asymmetric arch, T-GARCH, P-GARCH. So you can go towards that to improve your results. Thank you very much for watching.